Hello all, welcome back to my channel. In today's session, we'll be discussing the algorithm where we will learn how to convert a character to number conversion. All right, so let us go ahead and see what is the problem statement is. The problem statement says that given the character representation of an integer, convert to its conventional decimal format. Now, what exactly is the meaning of this? Here we are trying to convert a given number which is a character representation into its decimal format. So a character representation of an integer can be written like this. So here if you see it is written within the code. So the moment you write it within the code, which is considered as a character representation. But we want it to be in the integer representation, that is simply 356 without the quotes. That is as simple as that. We need to do that. So in order to understand the logic behind this, we should first understand how exactly the character representation and integer representation is different and how the working of them inside the computer happens, as in how they get stored. So in order to understand that, let us see how decimals are stored in memory. So any decimal values, it is stored in the form of binary. So we all know that. So integers will be stored in a computer using 4 bytes, that is 32 bits of memory. So MSB, that is the most significant bit. So in this case, if you are saying most significant bit is used in order to represent whether it is a positive number or a negative number. So 0 indicates that it is a positive number. And if it is mentioned 1, it indicates that it is a, so this is MSB, it indicates that it is a negative number. So in this case, I have given you example of 65. So these are 32 bits. So if you see here, it is 65. So I hope everybody is aware of how to convert. All right. So this represents 1, this represents 2, this is 4, this is 8, this is 16, this is 32, and this is 64. This is 32 and this is 64. So here we have 64 plus 1 is nothing but 64 plus 1 is nothing but 65, hence the representation in the memory. So this is how we will usually represent. Now there is also something called as ASCII representation. So how does the characters get stored in the memory? So we saw how decimals get stored. Now characters, this is how a character gets stored in a memory. So for all the characters, there is something called as a ASCII value, that is American Standard Code for Information Interchange. As you can see, for small a, the value is 97. For small b, it is 98. Hence, it is there for like that for all the values, A to Z capital, A to Z small, 0 to 9 for character representation of a number. So this is what we are dealing with today. So we are trying to convert this character representation into a regular decimal value is what our concern is. So the moment you write any number within quotes, for example, if I'm writing within quotes 3, the value which gets stored is 51. It is represented as 51 in the memory and not 101. Okay, so the binary conversion of 51 will be stored. That is why I have given it here. As you can see, if I say 0 character representation, instead of 000, it will be this value which is stored, which is nothing but 48. So we want to convert a given number from this representation to the exact integer representation. I hope this is clear. So what we need to do for that? So we already know the ASCII value. So taking this in mind, we are going to be converting our values. Okay. So another characteristics of this you should see, if at all, for example, I take 8, which is nothing but represented as 56. If I subtract the character value, ASCII value of 0, that is 48. If I'm subtracting 58 by 48, the value, whatever I get, will be exactly the value of that particular digit. So here, when I want to subtract, of course, I will carry 1. So 16 by minus 8 is 8 I'm going to get, and then which is nothing but 0. As you can see, what I got is nothing but when I subtracted the character ASCII value of that character representation of that particular number minus the character ASCII value of the 0, I will get the actual digit. Now, using this logic, we are going to convert the character represented integers into their decimal value. All right. So let us see the algorithm for that. So the algorithm simply says that start, declare a number n, I and value. So these are the three values I'll have n, and then I will take I, and also I will take a value. These are the three variables. Value I'm going to initially say it as 0. Read the character representation of an integer n. Okay, so in n, for example, if I'm taking, let us take the n value as 725. This is the value I'm going to take. Now what is going to happen is read the character representation. So we have done that. Now loop over the character in n from left to right to the following step. So in this character itself, we are going to loop. So I'm going to start from 1 to n. That is, I will start from I'll start from 1 to 3. Okay. So value is equals to value into 10. So value is equals to value into 10 is nothing but value I have 0. Value is equal to value into 10. Initially when I do, it will be 0 itself for I value. Okay. And then I will say value is equals to value into 10 plus ASCII value of ith character. So initially the ith character is nothing but 7. So ASCII value of 7, as I told you before. So let me just write ASCII value of 7 is 55. ASCII value of 2 is 50. And ASCII value of 5 is 53. So just keep this in mind. Okay, these are the ASCII values. So what I'm going to say is value is equal to value into 10 plus ASCII value of the digit minus ASCII value of 0, which is nothing but 48. So when I say that, I'm going to get 0 plus, this is nothing but 7. So which is nothing but now value has become 7. Value has the value 7. Next, I will move the I value, increment the I value, and then the digit. Now, the next digit we are going to read is 2. So, whenever I read, it is going to be value is equals to, so see this formula. So, this is the formula I'm talking about. So, next, I'm going to say value is equals to, now I have value as 7 into 10 plus next value, the ASCII value of 2 is 50. 50 minus 48. Okay, so this will simply give me 70 plus 50 minus 48 is nothing but 2, which is nothing but 72. Now value has 72. Okay, so this was the first iteration. This was the second iteration. Now third iteration is going to be once again value is equals to value, which is 72 into 10. And then ASCII value of the character, the next character which we are reading is 5, which is nothing but 53 minus ASCII value of 0. ASCII value of 0 is, as we have seen, it is 48, which will give me 720 into, sorry, this is not into, this is plus 53 minus 48 will give me 5. Okay, which is nothing but 725. Okay, so when we come back to this loop, for loop will end here because we have reached the end of the value n, and hence we are going to, we will end this loop and then directly print the value. Okay, which is nothing but 725. Now you might wonder, once again, if you have not understood, you might wonder that I'm taking the value 725 and yet again printing 725. What is the difference? Please understand, this initial n value, whichever we have taken, was a character representation. It was given input something like this. Within quotes 725. So when I do that, it is nothing but a character representation. The task for given for us to convert it into an integer representation. So that is what we did. Now when I store 725, directly it will be converted into the form of 7, 2 and 5, and it will be stored in that way. But in this case, it would have been taken the value, ASCII value of 7, that is 55, 50, and 53. It would have stored in that way. But here now it will be directly stored as 7, 2, and 5. That is why it is the integer representation of the number. All right, I hope this is clear. So that's all in today's session, students. Thank you for watching. Keep learning.